Okay, so good evening, everyone. I hope I'm audible. So today, let's discuss the mock test, subjective mock test that uh, was taken in RSM, I guess somewhere around last week. I just got hold of the four-question paper. I will forward them to the group. Let me do it right now. So yeah. So as far as I saw, all of them are mostly objective except the last two. So I will discuss the second last question paper. So let's start with the first one. So this is a 2 hours test with total marks 80. ICICMA entrance 2020. The first question is, let A be the sum of decimal digits of 444 power 444. So digit sum of 4444 power 4444. So that's the definition of A, and B is the digit sum of A. And we have to find the value. Okay. We have to find the digit sum of. So digit sum of B. That is the thing we have to find. So those of you who gave this mock, did all of you have got your papers or answer scripts back, or know the marks like anything? Hello. So did anyone try this problem during the mock test? I mean. Okay, so first let us try to find a bound for the digit sum of A. So we will use logarithm for that. So to find a bound or to get a bound, we take log of 444 power 444. And that's equal to 4444 times log of that base. So it's a 4-digit number, so it's of the order of 10 power 4. So this is less than or equal to 4444 times 4. Or should I say not less than, of the order of. So that's 16776, I guess. No, sorry. 177. So this is kind of an approximation for the value of a. Now b is the digit sum of this number. So how many digits does this have? 1, 2, 3, 4, 5. So 5 digits. So obviously, okay, let's do it step by step. So sorry, this is not the bound for a. This is the bound for log a, right? So a has around 17776 digits in its decimal expansion. Therefore, a is less than or equal to, in the extreme case, all the digits are 9. So that's the upper bound for a. So that is like 4, then 8. So this is an upper bound for a. Okay, now we can take log 1, or we don't even need that, 1, 2, 3, 4, 5, 6. So a has only 6 digits. So b is less than or equals to 9 times 6. B is the digit sum of a, that's just 54. So b is something less than or equal to 54, and we just need to find the digit sum of b. So like this is just a 2-digit number less than 54, so we can try out all the numbers from like 1 to up till 54. So like we still have some kind of what do you say, uncertainty. So our uncertainty is of order 54. So we have shortened our uncertainty from something like 444 power 444 to this number. Now to pinpoint the exact sum, we can check for congruences. So you can use any number. Let's start with 9. So checking. So checking congruences modulo 9. So what is the first number congruent to? 4444. Dividing by 9, we get 5 is overkill. So 4, 6, 84, 9, 81, 34, and it's 5, not 5, sorry. Again 4, not 4 also, but 3, 27, 7. So around, so we are getting a remainder of 7. Someone is trying to join. Okay, so for those of you who joined just now, I'm discussing the second last question paper, subjective mock test of RSM, that was held last week. So 444 pass is congruent to 7 mod 9. So 444 power 444 is congruent to 7 power 444. Now we can use our Euler's theorem to find the value of phi of 9, that is 9 times, there is only one factor. So 9 minus 3. So it's 6. So 7 power 6 should be 1 mod 9. We have to check. So let's check. 7 square is 49. This is 4. 4 sevens are 28. Oh, actually, okay, so 7 power 3 is only 1 mod 9. So 7 power 6 will, of course, be 1 also. So here we can do better than Euler's theorem. So we have to take mod 3 now. So that is like 3 ones are 3. So it's 1 mod 3. Therefore 444 power 444 is congruent to 7 power 1 congruent to 7 mod 9. So since our original number was congruent to 7 mod 9, and now see what happens when we like take the digit sum. Just for example, any number 37. So this number is congruent to 1 mod 9, but its digit sum, that's 10, is also congruent to 1 mod 9. So it can be proved that for any number k, or suppose m, of the form 3 power k, for k in a natural number, x congruent to the digit sum of x. I guess we write it as tau mod 3 power k. For sufficiently large x. So it's true for, just a minute, I guess it's not true for, is it true for 3? Yes, it is true for 3. So like 37 is congruent to 1 mod 3 also, and 10 is also congruent to 1 mod 3. But like 8 is also congruent to what do you say, 2. So 2 mod 3. But 8 is not congruent to I mean, 8 is congruent to 8 mod 3, 8 mod 9. Actually 9 is pretty small, so if we take the third power, so 27, so 11 will be congruent to 11 mod 27, but the digit sum of 11 is 2. So 11 is not congruent to 2 mod 27. But that is true for 9. Basically, x has to be larger than 3 power k for this to be true. Okay, so why does this happen? So in a decimal expansion, suppose we have a number n. So we have some number is of the form a, b, c, d, E or something like that. So this is the, I'll assume this is the units digit, so it's 10 power 0, this is 10 power 1, and this is 10 power 4. So it's basically 8 times 10 power 4 plus b times 10 cube plus c times 10 squared plus d times 10 plus e times 1 or 10 power 0. So when we take mod 3 or mod 9 for that matter, any of them. Okay, let's take mod 9 since that's what I'm using in this example. So this is e times 1 is a, so ABC are digits here. So they are numbers between 0 to 9. So if we take mod 9, it will be a number between 0 to 9. Okay. So E will be E by for it matter. So like then D will 10 times D will be congruent to D since 10 is congruent to 1. So 10 square is also congruent to 1 and 10 cube is also congruent to 1. Yeah, so you see like this is just congruent to the sum. So that's what's proof the theorem for 9. Actually, this is not true for any general key, I think then. So k has to be, so k has to be either 1 or 2. It is also true for higher values of k, but then like the even places have to be 0 or something, since if we take it won't be true. Alright, like that we have to take 99, not 3 power k. Okay, so for this example we have 444 power 444 is 7 mod 9. So a, the digit sum of 4444 power 4444 is also congruent to 7 mod 9, and so is b. So b is also congruent to digit sum of a is congruent to a is congruent to 7. So digit sum of b, the thing that we have to find, is also congruent to 7 mod 9. Now see what is the value of, what is the bound for b that we found. Yeah, so the bound for b was 54. So it is the bound for digit sum of b. So digit sum of b can be at max the sum of 54, that is 9. Hence tau b is a unit digit, like a single digit, not a 2-digit number, right? And we know tau b is also congruent to 7 mod 9. So that implies tau b is exactly, like it has to be 7 or it has to be minus 2. Minus 2 is, this can't be right, like since minus 2 is not, can't be a digit. Someone just joined. Okay, so we get digit sum of b equal to 7, right? Is that clear? This was pretty easy, I believe. Just have to take log and take bounds. Okay, so the next problem, just a minute. So the next problem is that from Combi. So in a party we have n boys and n girls, and each boy is paired to a girl in some with some algorithm like B1 is paired to B2, B3 is paired to G2 or some G1, I mean something like that. So all the boys are distinct, all the girls are distinct, and each boy is paired to some unique girl. So we have n pairs. So this gives us n pairs, boy girl pair, I mean, and also given the difference in height, difference in height of each between the boy and the girl in every pair is strictly less than 10 centimeter, and we have to show the kth tallest boy, the difference between the height, so the kth tallest boy and the kth tallest girl, the difference between their heights is also less than 10, where k is a number between 1 to n. So I have to prove this one. Just try to think in this is obviously a problem of PHP. So think about what are the balls and what are the boxes. Think for 5 minutes. I am also thinking. Okay, so the first step is to assume some order between the boys and the girls. So without loss of generality, let's assume B1 is less than or equals to B2 less than or equals to B3 up to Bn. The G1 is less than or equals to G2 less than or equals to up to Gn. Now we don't know the pairings, but so the kth tallest girl and the kth tallest boy. So this is the order of heights. So the kth tallest boy would be, okay, so then let's reverse the inequalities. It would be easier for us to find the kth tallest person. So now B1 is the tallest person, B2 is second tallest person, so BK is the kth tallest person, tallest boy. Similarly, GK is the kth tallest girl. So if the difference between their heights is, we are assuming this, so let's assume it's greater than or equals to 10. Right, so somewhere we have here K and this is K. So now BK, or we can even assume further that the boy is taller, so BK, so BK minus GK is greater than or equals to 10. Right, so how many taller boys are there? So this must be true for all BI minus GJ, for all I inside. So it's true for K, it would be true for K, K plus 1 up till the tallest boy. Sorry, not K plus 1. Yeah, K, K minus 1 up till the tallest boy 1. And for all J, so it's true for K and for all the other shorter girls like till N. So how many how many possible boy girl pairs are there who have difference in heights greater than 10? So we have k of uh, yeah, k of them here, and mm, n minus k plus 1 of them here, right? Okay, so how many pigeons are there? K times n minus k plus 1 many, right? Or I can say like all the boys um, B1, B2 up till BK are taller by at least 10. So minus GK plus 1 up till GN. So this difference is greater than or equal to 10. So just a minute. So we have n pairs, and here there are k plus n minus k plus 1 many persons on the left hand side. If we pick hmm, so if we pick all, we choose all these boys and girls, so we have n plus 1 many persons, and we know that by PHP in a group of n boys and n girls, picking any n plus 1 of them implies we have picked a pair. So we have some, so here we also have picked n plus 1 of them, so we have picked a pair. So we have at least one pair in these n plus 1 persons. Now, since by our definition, two of the boys won't be in a pair and two of the girls won't be in a pair, so that pair must be some boy here paired to some girl here. So some boy, so some ith boy is paired to some jth girl, and like that. And all the boys are greater than all the girls by at least 10 centimeters. So that's a contradiction, since we assumed that in all the pairs, all the height differences were strictly less than 10. So all so like what was the question? Yeah, so that proves that, so the kth tallest boy and the kth tallest girl have heights less than 10 centimeters. Is that okay? Right. So anyone, any doubts? So this was also pretty easy problem from PHP. Now the third one. So third one says there is a quadrilateral. So there is a quadrilateral ABCD such that convex or concave, nothing is said about that. Hmm. Suppose this is a quadrilateral. So we have A divides B plus C plus D. The sum of three sides is divisible by the fourth side. and B divides A plus C plus D, and C divides A plus B plus D, and lastly D divides A plus B plus C. This is the condition we have to show. Not all sides of the quadrilateral ABCD are distinct. So we have to prove the existence of at least two sides which are of same length. So let's always write for a few minutes. So, so here this is a bit difficult. This problem, I mean. So we have to use some kind of inequality to find some kind of an upper bound for the sum of the sides and all of that. We'll obviously start with the triangle inequality. So, but how to find triangles in here? This is a quadrilateral. So we will draw the two diagonals down to make. Sorry, and to split the quadrilateral into four triangles. Okay, from from triangle inequality, from triangle inequality we have AC greater than or sorry, not less than or equals to AB plus BC, which is equals to A plus B, and BD greater than or less than or equals to AB or just a minute, not ABD. Let's try with AD. So AD is less than or equals to AC plus CD. Right, so we're considering the triangle ACD. This is from triangle ABC. So from these two inequalities, we get AD is less than or equals to AB plus BC plus CD. Right, and AD is D. So we got D, the fourth side is less than or equal to sum of the first three sides. So similarly we can get like A is less than or equals to B plus C plus D, B is less than or equals to C plus A plus D, C is less than or equals to A plus B plus D. And the fourth one is this one. So we got four inequalities, similar inequalities. Now we have to prove that all of them can't be distinct. So, so we can assume, for the sake of contradiction, that A, B, C, D are indeed distinct. Now we can assume without loss of generality, A less than B less than C less than D, all of them are strict inequalities. So that makes D the largest side in that quadrilateral. Now we can, so like we can say things like A plus B plus C plus D is like some L times A. Similarly, it is also equal to some. So we are taking this as this. So what was the question? Like A divides B plus C plus D. So B plus C plus D is of the form some QA. So QA plus A is equals to LA. Right. So Q plus 1 is L here. Similarly, it is also some MB and also some NC and also KD. So it's divisible by both, like all of A, B, C, and D, and all of them are integers. Right. So here LM and K are integers. Actually, natural numbers. So So now D is the larger side, right? So B plus C plus D is less than or equals to D plus D plus D. Not equal to, it's strictly less than. It's 3D. And so so we have A plus B plus C plus D less than 3D plus D, and this side is, we know it's LA or MB or NC or KD. So observe that, just a minute. So D is obviously from this inequality, this one, D is less than or equal to A plus B plus C. So we have found both an upper bound and a lower bound for A plus B plus C. So by this equation we have, so call it equation number double star. Let this be equation number star. So this is from star and star star. Right. Since this is also an integer, so it has to be this 2D. Since since D divides A plus B plus C. So it has to be of the form some KD. And K has to be greater than 1 and less than 3. So it has to be 2. So we got A plus B plus C equals to 2D. So we have 2D equals, oh actually then, okay. So then A plus B plus C plus D, the upper bound that we were getting as 4D or something, that is actually 3D. So this is 2D. Therefore LA is 3D, implies A is 3D by L. Similarly B is 3D by M, C is 3D by N, and uh, D is like, it's obvious. So D is 3D by K. Uh, just a minute. Actually, K is 3. Okay. Now, now we can again use the same equation. This one. This implies A plus B plus C equals to 3D by L plus 3D by M plus 3D by N equals to 2D. Cancelling out D since it's a positive integer, we get 2 by 3 equals 1 by L plus 1 by M plus 1 by N. Now we have to use some kind of inequality. So like first observe that assuming A, B, C, D are all distinct, it forces L, M and N to be distinct. So observe that L, M, N are all distinct. Why is that true? Since if L is equals to M, so L is equals to M, so that implies A plus B plus C plus D equals to LA equals to MB. Right, so LA equals to MB. That implies we can just and L equals to M, so we can cancel out L and M. So that means A equals to B, which is a contradiction since we have assumed all of them to be distinct. Okay, so you see why this holds. So now Lm and n are all distinct integers, positive integers, all greater than or equal to 1. So what are the possible values of L? So L can be greater than or equals to 1, 2, 3 or 4. So if L is greater than or equals to 4, M is greater than or equals to 5, we're assuming L to be the smallest of them. So like without loss of generality, we can assume some order. Okay. So n has to be then greater than or equals to 6. And let's see how much 1 by L plus 1 by M plus 1 by N is. So it's 1 by 4 plus 1 by 5 plus 1 by 6. So 6 and 4 is 12. It's 60. So 15 plus 12 plus 10, 37. So if we compare 2 by 3 with this, we get 21, 101 and here 120. So clearly 2 by 3 is larger. Oh, and this is a I mean, this is impossible, which is impossible since this has to be true. Since 1 by L plus 1 by M plus 1 by N is 2 by 3, and 2 by 3 can't be strictly less than 2 by 3, right? So L can't be greater than or equal to 4. So L is strictly less than 4, so L is greater than or equals to 3. So L is either 1 or 2 or 3. So we will check for each case. Case 1, L is equals to 1. L is equals to 1 means A plus B plus C plus D equals to LA equals to A, which implies B plus C plus D is 0, which is also impossible since all the sides are positive. So case 2, L equal to 2. Here we have A plus B plus C plus D is LA equals to 2A. Plus A equals to B plus C plus D, which also violates our triangular inequality since A is less than or equals to B plus C plus D. I mean, not less than or equals to. This equality only holds for the degenerate case when the quadrilateral is actually aligned. And the last case, L equals to 3, we have 3A, and it is also equals to that number 3D, right? And that implies A equals to D, which is a contradiction to our assumption that all of them are distinct. Remember, we found that, where was it? Here. So LA equals to 3D. This means K is equals to 3 actually. Since D is the largest number, L has to be less than 3. So all three cases we arise to a contradiction. So So by contradiction, A, B, C, D are not all distinct. Proved. Now, any doubts, queries, questions? Pose them right now, or I will move on to the next question. Okay, so let's move on to the next question. We have This was question number 3. We have still left with 5 questions. I won't be able to complete them. So the fourth question. So there is a convex quadrilateral BCED such that angle BDC equals to angle CEB. So BDC and CEB. So these two angles are same, which obviously implies this is a cyclic quadrilateral with this as a chord and angle D and E are on the circumference. So you have a circle, the chord, which is the point D. Sorry, this is the point E. This is the point B. This is C, and these two are equal. Further, it says, okay, this point is A. The diagonals intersect. Okay, these are 90 degrees. So that forces BC to be the diameter, since 90 degrees is a semicircular angle. I have to draw it once more then. Sorry. So diameter. I hope this is the center. This is BCD. Is it BCDE or BCED? It's BCED. Wow, that's strange. So this is A, this is the center of the circle. F and G are the midpoints of DE and BC. So this is F, this is G. O be the circumcenter of triangle BAC. So BAC. How on earth will I draw that circle? So let me try to draw that circle. So something like that has center at O. So this is the point O. BC, BAC. Prove that the lines AO and FG are parallel. So we have to show AO and FG, these two are parallel. Looks pretty challenging. So as always, try it for a few minutes. Let me also try it. Okay, uh, observe that you already observed that G is the circumcenter of the quadrilateral. Now, if so, D is any chord. D is another chord of that same circle. So F GF will be GF will be perpendicular to it. So GF is perpendicular to DE. Not only that, the triangle GDF is congruent to triangle GFE. So so to show these two line segments are parallel, we somehow have to show transversal angles on the same side of the transversals are same. So or they sum up to 180. Sorry. So we have to show enough to show angle FGO plus angle GOA is equals to pi 180 degrees. So what is FGO? So FGO is this angle. Just a minute. So there's just any random circle and a chord, and a perpendicular is dropped. And the construction of O is pretty difficult to. Hmm. So it's the circumcircle. Mm-hmm. Understood. Some diameter. So this angle and this angle add up to 180. Oh, and yeah, what is the definition of a circumcircle? A circumcenter. It's the it's the intersection of the side perpendicular bisectors, right? So that shows GO is actually perpendicular to BC. So this is 90. Since circumcenter is side intersection of side perpendicular bisectors, this implies GO is perpendicular to BC. If that is true, okay, then what is FGO? So like that proof that implies angle BGO, angle CGO is to 90. BGO and CGO are all 90s. Then FGO is angle FGB plus, or I can say that reflexive angle, or it doesn't matter. So like, so how should I say it? Let me write a small r here. So F reflexive angle FGO, that is I am talking about this angle. Right, let me write it in purple. So reflexive angle FGO. Let me make it smaller. So here is a small copy for us to refer. So reflexive angle FGO is equals to 90 degrees plus angle FGC. That is equal to, what is FGC? FGC is FGE plus EGC. So FGE plus EGC. Okay, obviously we are breaking it in terms of GE. So let me join that code here. That is equals to 90 plus. Now we know triangle DGF and GEF are congruent, so that means GF is the angle bisector of angle DGE. So this is half times FGE is half times angle DGE, and EGC is as it is. So it's 90 plus. Now okay, so that half of angle DGE is actually equals to half is equals to DBE. since the chord DE subtends both the angle DBE and angle DGC, one on the circumference and the other on the center respectively, which differ by a factor of 2. Chord sharing, that is equals to DBE plus, what is EGC? So EGC, we can make it twice of CDE. Right. Or CBE, let me do it B. CBE. Now CBE plus DBE. So that means it's angle DBC. Just a minute. CBE and DBE. So plus 1 CBE is left out. So what is 90 plus okay, I will check it later. So now let's try and find the other side. So the other angle is angle GOA. Remember, we wanted to show angle FGA and FGO and angle GOA sum up to 180. So what is GOA? GOA. So GOA is GO GOC minus AOC. Right. So if we join these two, so we have GOA equals to angle AOC minus angle GOC. GOC. What is GOC and AOC? AOC is the angle at the center, so it's twice angle ABC. Twice angle ABC minus GOC GOC. Oh, again now G triangle BOG and GOC are congruent, so like OG is the angle bisector of BOC. So it's half times angle BOC. Right. So now we have to somehow link these two angles. We have ABC. So ABC is one of those common angles. So ABC is actually CBE. So So this is ABC. So if we sum them up, just a minute. So we want to show 180 minus 90 plus angle DBC angle ABC, that is this angle, plus 2 ABC minus half angle BOC, this is 180. So we have to show these two are equal, right? So 1 ABC cancels out. So we have to show 90 plus DBC equals to ABC minus half BOC. So what is BOC, relationship between BOC and DBC? So BOC and DBC. Is also 90-degree at the top, DBC. So how to proceed? DBC. This angle plus this angle. There we have POC. Sorry, this. No, it's okay. DBC. BOC. I'm making some kind of mistake somewhere. Just let me analyze it. So here these triangles are perpendicular. We have to show these two parallel. So let's pick this angle, this angle. This angle is GOA is angle COA minus GOC, and the angle FGO is 90 plus angle FB FGB. The GOC is does this O lie on the circumcircle of the quadrilateral BCED? Why should that be? These are 90 degrees too. This is 90, this is 90. These two angles are equal. These two angles are equal. And then these two angles are in turn equal, so these two are also equal. So what does that show? So OA is also the angle bisector of BAC. BAC. This angle is this angle, and this angle is this angle. And these two angles, the same as these two angles, add up to so if this is alpha, this is beta, this is gamma, gamma, delta, delta, this is beta, this is beta. So 4 beta so 4 beta plus 2 alpha plus sorry plus it's 2 alpha. This whole thing is alpha and this whole thing is alpha. This gamma plus delta equals to 360. What can we say about gamma plus delta? Beta plus gamma is getting out of control now. Okay, I will try to solve it during this week and let you know the solution by next week. For now, let me move on to the next problem. So, okay, so this one says, so prove that sum over items from 1 through 89 10 square I. This is an integer. How to solve this one? So what is 10 square x? It's cos x squared x minus 1. 10 square theta is 10 square 90 minus theta. Oh, sorry, these are only the odd terms. So it's basically 0 to 44 to y plus 1. To show this is an integer. Any idea how to proceed? Not quite. Oh, I guess we can use that AP formula for trigger for 10. This eraser is so small. So first claim is 10 nx equals to nc1 tan x nc3 tan cube x dot 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 up to infinity, I mean, or nc whichever, like, is it, if n is odd, then so 2k plus 1, then 2k plus 1x, and then the even terms are 1 minus nc2 10 squared x plus nc4 10 4x, like that. Okay, so proof will be by induction. I'm not proving it right now. So if we use that formula, then observe that using the above, tan 180x is 180 the odd terms. I'm writing t for tan x for shorthand. The last odd term will be 177, 170, sorry, 179, divided by 1 minus till. Now we know tan of 180 times x is 0, right? So tan 180x is 0. Just a minute. If x is an integer, I mean. So that forces the numerator is 0. That implies this polynomial of odd degrees this is 0. So this is 0. That is the cell value of tan r, tan x. So it has to be real, right? I'm ruling out the trivial solution that x is 0. So now we can divide both sides by tan x or t to get 179. It's minus actually, sorry. Now we can pair them up in 2, and 181 minus, sorry, just a minute then. So what do we need to find now? So this equation has its roots, which are uh, between 0 to 90, right? So x is in between 0 to pi by 2. So sum over just a minute. I'm taking in degrees, so it will be 0 to 90. Okay, it's already past 10. I will end the class here right now, and we'll discuss the rest of the problems along with this and the previous one next week. Cool. Okay. Is that fine? Okay. Bye then.